All right, hello everybody, it is Mrs. Griswold here. Today we are on Chapter 8, Day 6, about factoring a special situation. After today we will have learned all of our factoring techniques and we will be pros. So our learning targets for today are I can factor a difference of squares, and the difference of squares is our special situation for today. So before we start talking about how to do it, let's talk about what it is. So factoring a difference of squares, okay? A difference of squares, a couple things that we have to recognize, okay? So they're all going to be binomials. Remember, a binomial means two terms. And they're going to be in the form of ax squared minus c, where a and c are perfect squares, okay? So you have to be able to recognize when this situation comes up, because it won't always be this way. So we have to be able to tell, okay? So before we get to that, what is a perfect square? Now, you might have heard this before, you might be familiar with it, but a perfect square is like 2 times 2 is 4. 4 is a perfect square. 3 times 3 is 9. 9 is a perfect square. 4 times 4 is 16. 16 is a perfect square. What a perfect square means is when I take the square root, it's a whole number. Okay, you might not be super familiar with square root, but that's kind of why we call it a perfect square. But we think all the way through perfect squares, 1 times 1 is 1, which means 1 is a perfect square. 2 times 2 is 4. Those like that, and you continue to go up. Now, if you're not very familiar with a perfect square, we're going to use our factor cheat sheet again. So remember, the first page is all the list of factors. The second page is a multiplication table. Now, any multiplication table will be helpful. This one is kind of hard to tell, but if you notice along the diagonal, right, or if you look here, it's 3 times 3, right? 36 is 6 times 6. So along the diagonal is the same number multiplied by itself, and that gets us those perfect squares, okay? If you see this and it's a PDF and you can't rotate it, you do need to download it so that you can rotate. Okay, if you print it, then you won't have to have that problem because you can just rotate it on your own. So if you're not sure, if you see a number like 144 and you're like, is this a perfect square? You can check the diagonal and then you can see, oh, what times what gets me 144? Oh, it must be 12 times 12. Okay, and if you Google something, they might be color coordinated, which will make it a little bit easier. Okay, so 1, 4, 9, 16, 25, 36, and so forth. Those are perfect squares. Those are the numbers that we're going to look for. It's going to help us identify this. Okay, the other key is difference. Notice I have this arrow here too. Difference means subtracting. Okay, if it's an addition sign, it doesn't work, and I'll show you that in a little bit. Okay, so here's our first example. It says factor x squared minus 64. I'll tell you the shortcut, and then I'll explain a little bit why it works. Okay, so this is what Delta Math is going to tell you. It's all the information it's going to give you. It's going to say square root the first term. Okay, one thing you need to know is that if you square root x squared, and you'll definitely learn this in Algebra 2. If you don't know, okay, square root the first term, square root of x squared, just like addition and subtraction are opposite signs, the square root and the square are opposite signs, and that leaves me with just x. Okay, so whenever you see x squared, y squared, p squared, m squared, the square root of that is just going to get rid of that exponent. Okay, Then square root the second term, the square root of 64. We're going to ignore that negative because we'll take care of it at the end. Okay, square root of 64, you can look to see what two numbers multiply to give me 64, or you can use Delta Maths calculator and hit square root of 64. And right there, it gives you 8. Or you can find 64 on your multiplication chart and be like, oh, it's 8 times 8. So there are a couple different ways you can do that. Okay, those are the first two steps. Square root the first term, square root the second term. Now what we do is we're going to put them together and then we'll check. Okay, once we show the shortcut, I'll go through and show you why. Okay, whenever we're doing difference of perfect squares, our final answer, we've got our two parentheses, our two sets of parentheses, right? But then in the middle, one sign is positive and one sign is negative. And that's always going to be how we factor perfect squares, right? So what we do with this is the square root of the first term will go in the first spot. And the square root of the second term will go in the second spot. Okay, and that is my answer. Now you might be kind of like, what? How did we even get that? Why does that work? Even though it is a shortcut, I think it is important too that we know how to do the original problem. Let's see, I've got x squared minus 64, and I want to factor. I'm going to show you why this shortcut works, why we can do that, okay? If you notice, we're used to trinomials that have the x term, and this is missing that x term. So to kind of go backwards, we can add that x term by doing plus 0x in the middle minus 64. Okay, now it looks more like what we've been doing before. Okay, the leading coefficient is 1. So we can just figure out, oh, okay, what multiplies to give me negative 64, but adds to give me 0. What multiplies to give me negative 64, but adds to give me 0. Well, we've got positive 8 and negative 8. Well, that first one got a little swirly. And then you know, okay, yeah, I know how to do that. X plus 8, x minus 8, and we're good. Okay, so you might be wondering, well, why can't I do that all the time? Well, perfect squares get pretty large pretty fast. If you look on this sheet, right, we've got 100, 121, 144, 169, 196. Those get pretty high pretty fast. So if Delta Math gives you a problem that's a difference of squares, it could look like this. 121x squared minus 81. Right? Those are both perfect squares. If we did the box method or the x method and we added the 0, and we tried to do the x, what are we going to multiply to? Remember, it's a times c. This is 121 times negative 81. I don't even have enough room in here to write it. It's negative 9,680. That's what we would need to multiply to and add to 0. I don't know about you, but I don't want to have to list all of the factors of negative 9,680. So that's why it's nice for us to use the shortcut. Okay, but I wanted to show you why it works by doing something that we're used to doing. Okay, so we find the square root of the first term. We find the square root of the second term. Then we put it together. One has a positive, one has a negative. We always follow that pattern. All right, so here's another one. I've got the same top. Remember, factoring difference of squares. Difference means subtracting. Squares is A and C have to be a perfect square. Okay? When we get the question, you want to make sure that A and C are perfect squares. Is 9 a perfect square? Is 4 a perfect square? If you want to check, because you don't know, see, are those numbers along my diagonal? Okay, 9 is and 4 is, so those are perfect squares, which means I can use the shortcut for perfect squares. So the first step is to square root the first term. So square root of 9p squared. The square root of 9 is 3. And then remember, the square root and the square will cancel each other out, leaving me with just p. So the square root of the first term is 3p. The square root of the second term is the square root of 4. Remember, we ignore the negative because we take care of it with our final answer. If you tried to take the square root of -4 in your calculator, you would get an error. Kind of an interesting thing, but you'll learn more about that in Algebra 2. Square root of 4 is 2. Then we always have our outline put together. One's positive, one's negative. Square root of the first term goes in the first spot, 3p. Square root of the second term goes in the second spot, 2. And then we do the same thing, 3p and 2. Okay? And again, you could check when it's these smaller numbers, because it's doable when we've got 9 and 4. Like you said, it's not as doable when we've got like 121 and 81. But you can check your work. You can FOIL to check, if you remember how to FOIL. You could box it to check, right? Make the box 3p, positive 2, 3p, negative 2, and go ahead and fill in the box and make sure that it gets you 9p squared minus 4. Okay, now it's time for us to try. Follow the same pattern. So you try square root of the first, square root of the second, and then you're always going to have parentheses with opposite signs. So go ahead and do this problem. Pause the video. Try this problem. All right, hopefully you tried it and you got y plus 4 times y minus 4. Okay, square root of y squared is y. Square root of 16 is 4. And this is exactly what you would type into Delta Math. Parenthesis y plus 4, parenthesis y minus 4. Okay? Next one. Now Delta Math is going to show us where the x squared isn't always first, and that's okay. We still do the same thing. Square root of the first one, square root of the second one. The first one goes in the first spot, the second one goes in the second spot. So pause, try this. All right, hopefully you got 10 plus 2x and 10 minus 2x. So square root of 100 is 10. Square root of 4, oops, I forgot the x squared in there, is 2x. Okay, so 10 plus 2x and 10 minus 2x. Even though it's flip-flopped, again, the square root of the first thing goes in the first spot, and the square root of the second thing goes in the second spot. Last one I want you to try. Now this one is a little confusing, but 1 is a perfect square. All right, hopefully you tried it. The square root of 1 is 1, because 1 times 1 is 1. That's what, it's like so obvious that we forget. And then the square root of x squared is just x, so we get 1 plus x times 1 minus x. All right, so that is our special situation for today. Your homework is going to be review, to get us ready for the test next week.